Hello and welcome everyone. I am Kritika and this video lecture of mine will help you understand the chemistry of Shapiro reaction. So let's start with the basic introduction. Shapiro reaction was discovered by Robert H. Shapiro in 1967 and in some articles it is also known as tosyl hydrazone decomposition reaction. Shapiro reaction is an organic reaction in which a ketone or aldehyde is converted into an alkene through an intermediate hydrazone in the presence of alkyl lithium reagent. So, a ketone first gets converted into a hydrazone intermediate. Hydrazone intermediate is nothing, it is just an organic compound having formula C double bond N NH2, and further on treating with alkyl lithium and a proton source we get alkene. So before starting the reaction mechanism, let's have a look on some important key points which will help you guys recognize the Shapiro reaction. The first one is very obvious. A ketone will get converted into an alkene. The second is, it is a base catalyzed reaction and involves the formation of carbanion. Any strong base can be used. Generally, butyl lithium is used in this reaction. It is a strong base and will abstract the proton. Third is, we use two equivalents of the alkyl lithium reagent. As here we are using butyl lithium, so two equivalents of butyl lithium are used. The last and the most important one, a kinetically stable product is formed. That is, a less substituted alkene will be our final product. Kinetically stable product depends upon the rate of reaction, that is its kinetics. Kinetic stability occurs when the reactants react really slow. The slower the reaction occurs, the greater is its kinetic stability. This point will get more clearer later in this video. Let's see the general reaction. A ketone, that is heptane 4-one, reacts with arene sulfonyl hydrazine to give hydrazone intermediate, which further reacts with alkyl lithium reagent and a proton source to give alkene as a final product. Let's have a look on the reaction mechanism. Heptane 4-one reacts with arene sulfonyl hydrazide. In our previous classes, we have learned how the carbonyl group reacts with hydrazine compounds. Carbonyl plus hydrazine. The reaction takes place with the removal of water molecule, resulting in the formation of hydrazone intermediate. The same reaction occurs here when heptane 4-one reacts with this. A removal of water molecules occurs, H2 from here and oxygen from here. This intermediate is then treated with butyl lithium. Butyl lithium being strong base will abstract proton. Either it gets abstracted from the nitrogen atom or from the carbon atom. There are two hydrogens. We know the more is the electronegativity difference, easier will be the proton abstraction. Thus hydrogen gets abstracted from the nitrogen atom, resulting in the formation of this. Nitrogen gets the negative charge. the negative charge is in resonance with the double bond, so we can write it like this. Right. Also, lithium positive is present in a reaction mixture. So we get this. Now either you can show charges on lithium and carbon, or you can simply draw a bond between them. Like here I have shown. The second equivalent of butyl lithium will react with it. Again the proton abstraction will take place. Now the hydrogen abstraction can take place either from this carbon or this carbon. It is a symmetrical molecule, so hydrogen abstraction can take place from any carbon. I have shown from here. So a secondary carbon ion is formed over here. In the next step, loss of nitrogen gas takes place, as release of gas will increase the entropy of the system. Hence it is a feasible process and it is the driving force for the next step. Also ArSO2 get eliminated. Here again there is a positive and negative charge, so we can show a bond over here. The formation of vinyl lithium species takes place. We know at lithium and carbon there is a charge separation, delta positive and delta negative. So on hydrolysis, electrophile attacks over here and we get alkene as the end product. In this reaction we started from a symmetrical reactant, so there was no problem in abstracting the proton when second equivalent of butyl lithium was added. But what happens when a non-symmetrical reactant is used? Let's take an example. In this example, we are now using a cyclic ketone. And of course, an unsymmetrical one. When ketone reacts with tosyl hydrazide is toluene sulfonyl hydrazide. This group is tosyl. So when ketone reacts with tosyl hydrazide, the same reaction takes place. First removal of water from here, resulting in the hydrazone intermediate. Second step is abstraction of hydrogen using butyl lithium, which takes place at nitrogen atom. Then delocalization of negative charge. Then another equivalent of butyl lithium is added. Again the proton abstraction takes place. Now the question arises, from which side hydrogen will be abstracted? Either from this or from this. If a hydrogen is abstracted from this side, a tertiary carbon ion is formed, and if a hydrogen is abstracted from this side, a secondary carbon ion is formed. We know that secondary carbon ions are more stable than the tertiary ones. So hydrogen will be abstracted from this side. Negative charge comes on this carbon. So after the removal of nitrogen gas and tosyl group and following hydrolysis, we get a less substituted alkene, which is a kinetically stable product. Let's have a look on the regiospecificity of this reaction. So what is regiospecificity? It is just the preference of chemical bonding or breaking in one direction over all other possible directions. In this reaction, regiospecificity depends on the stereochemistry of C-N bond in the starting hydrazone. There is an evidently strong preference for abstracting the proton syn to the arene sulfonyl group. Here syn just means from the same side, like arene and the methyl group are in the same side. So proton abstraction syn to the arene sulfonyl group takes place. It is probably because when the hydrogen is abstracted from the syn side, that is the same side of arene sulfonyl group, it permits chelation with lithium ion. But hydrogen abstraction anti to the arene sulfonyl group is not possible. Anti just means opposite side of the arene sulfonyl group. It is not possible as it does not permit chelation, and also C double bond N is a rigid bond. You cannot rotate it to form the chelate, so it is not possible. The proton abstraction syn to the arene sulfonyl group is possible only. So that's all for Shapiro reaction. Thank you for watching, and do leave your doubts in the comment section below.